Question number 22. Two large conducting plates are placed parallel to each other and they carry equal and opposite charges with a surface density sigma as shown in the figure. Find the electric field, part A, at the left of the plates, part B, in between the plates, and part C, at the right of the plates. So, region 1, here, electric field due to this plus sigma will be directed towards left, and due to this minus sigma, it will be directed towards right. And being equal and opposite, they will get cancelled. In this region, both the fields will be directed in the same direction, so it will add up. And here, again, one will be directed towards right, another will be directed toward left, and hence, here, the field will also be 0. So, region 1, field due to this will be sigma upon 2 epsilon naught. It will be towards left, and field due to this will be minus sigma upon 2 epsilon naught towards right. So it will be 0. And second region, the region 2, field due to this plus sigma charge density, it will be sigma upon 2 epsilon naught, which will be directed towards right, and due to minus sigma charge density, it will be also directed towards right. So hence it will become sigma upon 2 epsilon naught, which will give sigma upon epsilon naught. And region 3, here field due to plus sigma will be sigma upon 2 epsilon naught directed towards right, and due to minus sigma, it will be field will be sigma upon 2 epsilon naught, but it will be directed towards left. Hence, negative sign sigma upon 2 epsilon naught, and the net answer will be 0. Now consider question number 23. Two conducting plates X and Y, each having large surface area A on one side, are placed parallel to each other as shown in figure. The plate X is given a charge Q, whereas the other is neutral. Find the surface charge density at the inner surface of the plate X, the electric field at point to the left of the plates, the electric field at a point in the middle of the plates, and the electric field at a point to the right of the plates. So, since charge Q is here, and here there is no charge, so charge on outer surfaces will be average of the total charge. So this surface will contain charge Q plus 0 divided by 2, that is Q by 2. So here charge will be Q by 2, and here also charge will be Q by 2. And since total charge is Q here, so this surface will also contain charge Q by 2, and due to induction, here there will be charge minus Q by 2. Now, there are 3 regions here. So first part of the question says, find the surface charge density at the inner surface of the plate. So here we have to find out surface charge density. So it will be sigma, surface charge density sigma equal to charge divided by area. So charge contained here will be Q by 2, and the area is A. So surface charge density will be Q upon 2A. Now we have to find out the electric field in region 1. So here charge division shown, Q by 2 charge this. So it due to this Q by 2, electric field will be in this direction. So we can say for region 1, field due to this will be in this direction. So we can write it sigma upon 2 epsilon naught. It will be towards left. Due to this Q by 2, it will be same sigma upon 2 epsilon naught towards left. And due to this minus Q by 2, charge density will be sigma. So due to this minus Q by 2, it will be towards right. So sigma upon 2 epsilon naught. And due to this Q by 2, it will be toward left. So sigma upon 2 epsilon. So these two will cancel out, and we will get sigma upon epsilon naught. But sigma is Q upon 2A, so it will be Q q upon 2a epsilon. Now consider a region 2. So region 2 here, due to this q by 2 field will be towards right, due to this q by 2 field will be towards right, and due to this minus q by 2 field will be towards right, and due to this q by 2 field will be towards left. So we can say sigma upon 2 epsilon naught due to this plus sigma upon 2 epsilon naught due to this q by 2, and then due to this also sigma upon 2 epsilon naught, but due to this q by 2 it will be directed toward left, so sigma upon 2 epsilon. So again we will get sigma upon epsilon naught, but sigma equal to q upon 2a, so it will be equal to q upon 2 epsilon naught a. Now consider region number 3. In region number 3, field due to this will be towards right, so sigma upon 2 epsilon naught, field due to this q by 2, it will be sigma upon 2 epsilon naught, and field due to this minus q by 2, it will be towards left, sigma upon 2 epsilon naught, and field due to this q by 2, it will be towards right, sigma upon epsilon naught 2. So again, these two terms will cancel out and we will get sigma upon 2 epsilon naught, but sigma equal to q upon 2a. So field will be q upon 2a epsilon. So in all three cases, fields are equal except the direction. Now, let's go to next question. Question number 24. Three identical metal plates with a large surface areas are kept parallel to each other as shown in figure. The leftmost plate is given a charge q and the rightmost a charge minus q, and the middle one remains neutral. Find the charge appearing on the outer surface of the rightmost plate. So as per rule, the outer surfaces, like suppose we write it 1, 2, 3, 4, 5, 6. So outer surfaces 1 and 6 will contain same charge, and that will be average of the two charges. So that is q minus 2q divided by 2. That will be equal to minus q by 2. So we can say this will contain charge minus q by 2 and this will contain charge minus q by 2. Now, since plate number 1 contains total charge q and here there is minus q by 2 charge, so total charge here it will contain charge, it will be q, total charge must be q, so minus q by 2 is already there, so there should be 3q by 2. Now if you find the sum of these two, it will be q. Due to induction, surface 3 will have charge minus 3q by 2, and since this plate number 2 is neutral, so another face will contain just opposite charge minus 3q by 2. Due to induction, again this will contain charge plus 3q by 2, and if we add the two charges, so what do we get? This is minus q by 2 and this is plus 3q by 2, and since total charge is minus 2q, so here this is minus 3q by 2, so this must be plus 3q by 2 to make it neutral, so this must be minus 3q by 2. Now if we find the sum of this minus q by 2 on outermost side, and this minus 3q by 2 in on the here on the surface number 5, so total charge must be minus 2q. Clearly it is minus 2q. Let's analyze it once again. So here this had charge q and this had charge minus 2q, and as per rule the outermost faces like face number 1 and 6 must contain the average of the two charges. So average will be q minus 2q divided by 2, that is minus q by 2. So this will contain minus q by 2 and this will contain minus q by 2. Now, since this plate number A, suppose we denote it as A, so A must contain total charge q. Here there is minus q by 2. So here there must be plus 3q by 2, so that the sum of the two may become q. Now, due to induction, opposite charge will be developed on face number 3, so that will be minus 3q by 2. And since this plate number B is neutral, so on the other side, there must be same charge but opposite. So it will be plus 3q by 2, hence it becomes neutral. And again, due to induction, here there will be opposite charge, that is minus 3q by 2. And here already minus q by 2 charge is there. So overall charge on the plate number C will be minus 2q. And our purpose was to get the charge on face number 6, and that is minus q by 2. Thank you for watching.